So while distance time graphs tell us how far, speed time graph tells us the pace. So how fast something is moving and how that speed changes. So if you've got a flat line, that means there's constant speed, like a car cruising on the motorway at 70 miles per hour. Now, if the line is sloping upwards, that's acceleration. So the driver is putting their foot down. And if it's a line sloping down, that's deceleration. So the brakes are on. Now, the clever part about all of this is that the area under the graph tells us the distance traveled. So the rectangle area is the steady speed over time, and the triangle area is the acceleration or the deceleration phase. So let's tie it all together with an example. Imagine a car. Yeah, okay. So a car travels at 10 meters per second for 5 seconds. Now that graph is a rectangle, so area is easy. 10 times 5, which is 50 meters. Now, if the car accelerated from 0 to 10 meters per second in 5 seconds, that bit of the graph is a triangle. So area we know is the half times base times height, which is half times 5 times 10, which is 25 meters. Now let's put it all together. So accelerate for 5 seconds, then cruise for 5 seconds. So the total distance would be 25 plus 50, which is 75 meters. So let's bring it all together. Speed time graphs, they show both changes in pace and the total distance traveled. They're like they're like the pulse of the journey. Now next, we'll move on and see the graphs that don't track movement at all, but instead they help us translate between the two different worlds.